Okay, okay, let's continue. Last slide we talked about entropy. Okay, so entropy is which symbolized by S. Okay, of any substance is the entropy gained by converting 1 mole of that substance from the perfect crystal at 0 K, and then this is the unit of the standard. Okay, standard entropy. Um, we will talk about this little circle later. Okay. The usual and what you saw here. Okay, we're talking about the increasing in entropy. In general, if you have a large molecule, they usually have larger entropy than smaller molecule. For example, if you have something like methanol, methanol has a structure that looks like this. Now, keep in mind when you see a structure like this, that you have all these bonds. The bond don't stay still. It actually moves around, it vibrates, it rotates, and then every time it rotates, vibrates, it causes friction and it generates this thermal energy. So the bigger the molecule, there's more bonds to rotate, to vibrate. Therefore, there is more dispersion of energy. So if you have a larger molecule, they usually have larger entropy. Um, Something like this. Okay, so you see that we have the ethane, and then this is methane. Ethane has 2 carbons. Okay, and then propane has 3 carbons. You can see that the entropy progressively increases as you increase the number of carbon. Another thing is that when you talk about phases, gas phase always have the highest entropy. And you see this water, liquid phase 70, and then gaseous water 189. Um, Again, if you have gas and aqueous, gas in gas phase will always have the highest entropy because the gas molecule actually disperse around. There's no intermolecular forces among the sample, the molecules at all. Versus aqueous, yeah, it is disorder, but it is still in the liquid phase. There's still intermolecular force between that compound and the water molecules. So the gas phase should have the highest entropy. So if you compare between liquid and aqueous, okay, so aqueous will have a higher entropy than the liquid because there is disordinate around disordinate organization. Well, I can't say organization. There's disordinate dispersion of the sample molecule in the water sample. Okay, lastly, let's take a look at example. Your homework is pretty much like this. If you compare between nitrogen dioxide and dinitrogen tetroxide, you know that, let's use a highlighter. Okay, you know that this, oh, what happened? You know that this molecule will have higher entropy because it is bigger. Now you have gas and you have solid. Gas will have higher entropy. If you compare between O2 and O3, you can see that, what color should I use? This one. Okay, you can see that O3 is bigger, therefore this will have higher entropy. Between liquid and gas, of course, gas will have higher entropy. Okay, and that's pretty much it for this lesson.